Okay, moving on. So a couple definitions discussing properties. Okay, so we have an intensive property and an extensive property, and I'll give you examples of both here. So intensive means it is independent of the amount of substance present. Okay, extensive means it does depend on the amount present. Okay, and two very easy examples of an extensive property: mass and volume. Because now if you think about it, the mass of something very much depends on just how much of it you have. Same with the volume. The volume very much depends on how much you have. But what about this intensive property? Okay, so intensive property doesn't matter how much you have. So I'm going to show you a cool trick. If I take mass divided by volume. We're going to see this formula on the next slide. I think one of the next slides coming up. Mass divided by volume is called density. And as it turns out, density is an intensive property. So that means if I have one singular droplet of water, or I have an entire ocean of water, it doesn't matter. The density of those two substances will be the same. Of course, the volume and the mass of a droplet of water compared to an ocean of water is very different, but both will have the same density. Okay? So anytime we take two extensive properties and divide them and ratio them, that will give us an intensive property. I'll say that again. Anytime we take two extensive properties, such as mass and volume, and I ratio them, it will give me an intensive property. These are the main ones we'll deal with this semester: mass, volume, and density. Okay? So then physical properties and chemical properties. So a physical property is a property of something that can be observed without changing it into another substance. And so when we talk about doing like something going from a gas to, let's say, a liquid to, let's say, a solid, we're not changing it to another substance. We're just changing it to another state. Okay? So if we have steam or water or ice, it's all H2O. It's just now in a different physical state. Okay? But what about a chemical property? A property of substance that can only be observed by reacting it to form another substance. So for example, when we reacted, I showed you in that example, two H2s plus one O2 makes two H2Os. These reactants will have different chemical properties than the product. Therefore, the reactiveness of these things, the way in which it makes an explosion, right? We said this is exothermic, goes boom. Sure, when you're looking at this picture later and you have no idea what this is, just make that sound effect. Then you'll know what it is, okay? So the fact that this makes an explosion, that's very much a chemical property. Okay, so let's keep going. So here is that formula I talked about. Mass divided by volume gives you density. This is a Greek letter rho, R-H-O. I don't expect you to memorize the Greek letters, though technically it does give the Greek letter rho. If you just want to remember it as D for density equals mass divided by volume, that's fine too. Okay? And so get used to seeing density in grams per cubic centimeter or grams per milliliter. So I'm going to prove this to you in a few slides. But 1 cubic centimeter equals exactly 1 milliliter. And I want you to know that. I want you to remember that a cubic centimeter is the same as a milliliter. So that's why we can report density in grams per cubic centimeter or grams per milliliter. And I want to show you something here with the math, okay? If I have my mass in grams and my volume, let's say, in milliliters, when I divide the two numbers, when I divide what the mass is by what the volume is, I'm going to get a physical number. But then I also have to keep track of the unit. And so that's where we get this unit of grams per milliliters or grams per cubic centimeters, because if we do math on the number, we have to do the same math on the unit, okay? And we're going to get into that in a lot more detail as we go. So here's just some typical densities. You can see these are all solids, and they're quite dense. These values are very large for density. Lead, 11 grams per cubic centimeter. I'll add gold to this list, AU for gold. It is one of the most densest substances on the planet. I don't have it memorized, but it's around 20 grams per milliliter. So if you've ever seen like The Italian Job, I don't know if you guys have seen that movie, but you know, they steal the gold bricks and they're holding them, and like they can barely carry this single tiny looking gold brick. That's because it's literally one of the most dense materials in the universe. So 1 milliliter of gold weighs about 20 times 1 milliliter of water. So water, this is a good thing to know, 1.0 grams per milliliter for H2O. And as you can see here, right, like diet soda, milk, soda, seawater, whole blood, all of those things are mostly water. And you notice like milk, soda, seawater, human blood, they're just slightly more than the 1.0 gram per milliliter. That's because there's extra stuff in there. Like in seawater, there's salt, right? In human blood, there's all kinds of stuff in there that actually give it a little bit more density than just ordinary water, okay? And if now we compare those to gases, so now if you look at my unit here, okay, look, this is gram per liter. So we're going to learn this here in the coming slides, but 1,000 milliliters equals 1 liter. So like when we put here that the density of air is 1.2 grams per liter, that actually means that it's 0.00124 grams per milliliter. And don't worry, if you don't see how I did that quick math, don't worry. We're gonna get into this in a lot more detail. This is just kind of introductory information for now. But so air is like 1,000 times less dense than water, and that makes sense because liquid water does not float on top of air. I'm not going to do that. I'm not going to pour my water out all over my keyboard to prove that to you, but I think you know if I pour this out, it's not going to float in the air. Okay. And so here you can see water vapor, which is actually a part of air, is also not very dense at all. Okay. So let's see, moving right.